Hello all, thanks for joining today's workshop. We are waiting for the speaker to join with us. So give us a couple of more minutes, then we'll start. Thank you.
Thank you very much.
Hello, Chris. Hello, everyone. Thanks for joining our today's session. Nice to meet you, Chris, finally. Hope you're well. So, hi, everyone. So I'll request everyone to be muted apart from Chris when he'll be giving the session. And we'll be making this event live on Facebook and other social media. So please let us know if you have any questions or any concern, so we can consider those. But please try to be muted while we have the session running on. And Chris, we want to give 1 more minute to the attendees to join.
Totally.
Then I'll make you a host so that you can see who is joining if you would like to, because you have to share this screen, and you can just admit them if you can. If not, then let me know. I'll try to get the host access again, and I'll try to admit.
Well, you can just be host, or if you want to be host, and then just give me capability to share my screen.
Yeah, I already given that one, but sometimes we have experienced that some of the hosts, they struggle.
It says host is disabled participant screen sharing. So, okay, I'll let you drive Zoom. I'm a Google guy, so
okay,
I'll let you drive this, but
yeah. Okay, sounds good. So let me go to the Facebook Live. Okay, I'll just make it live, and then we'll give 1 more minute. Then we'll start from there. Okay. Cool.
Awesome. And Q&A section's planned at the end, and I think we have 2 hours. I've got about an hour presentation to do. We can take a break, and then come back for a Q&A after that, which I'm happy to stay around, an hour and a half or however long it takes.
Yeah, that's perfectly fine. I just took given extra time in case you or the audience then need. But yeah, so if you feel that within 1 hour you can cover, then you can go to take a quick break and go to the Q&A.
Now let's hope my camera behaves, because it didn't behave last meeting.
Okay.
So sharing the presentation, my internet's stable, but evidently my camera and that complicated setup didn't want to behave. So we'll fingers crossed on that one.
Yeah, I hope so that it will be fine. But still, you can talk, right? If the camera doesn't work.
Yeah, absolutely.
At the screen. Okay.
Yeah. and I only have like 3 computers here, so goodness forbids I've got to join on yet another computer to continue.
Yep.
We can do that.
Yeah, that's perfectly fine. Just let me know. Just let me know if you see any issues. I'll be taking from there, and I'll also notify the audience. Okay. Okay. So now we are now live on Facebook. Okay, almost in our Facebook page, because we have a lot of sign up and followers from our group. So that's why we have made it live. Now I think we already covered 2 more minutes, so I think we have a good number of audience. Could you see that whether you have the share screen option on your side?
I am host disabled participant screen sharing is what I'm getting.
Okay, that's you getting, right? Okay. Okay, probably I have to make you host. So let me, before doing that one. So Chris, I'm not sure what's happening with my Zoom connection. So maybe in between, yeah, you just have to have a quick look into the people waiting to be admitted. So if you don't mind, just try to.
Yeah, it's going to be.
Yeah, bit of difficult, right?
Yeah. It'll be interesting. I'll check back if you want to interject and say, hey Chris, check on the waiting list. I think we got more people.
Yeah,
that'd be great.
I think I already admitted a lot of people. So now I
am the host.
Yeah, now you can crack on. Thank you.
And let's see if I can pop out. See if I can pop out the participant list. Where is more live stream? Where's that button for seeing your waiting room?
Just click on bottom, the participants. You can see some people show waiting, or you'll get the notification.
Yeah, I've got participants up. I see all the little windows.
Yeah.
So I got invite. That's the one I wanted. I wanted that little window right here, I think. And let me adjust everything. Yeah, definitely, folks on the call, thank you so much for joining us today. Be happy to take a bazillion questions, and hopefully you have a ton of questions after the presentation. I've got definitely got some time there. If you want to type them out in the chat, great. Raj, if you want to kind of track what's going on Facebook for me and ask those questions at the end, that'd be wonderful. I'm always open to sitting down with whomever for 15 minutes or so and going through any questions that they have.
Yeah, that sounds good. Just to give a very quick context to the audience, Chris, probably that would be really helpful for both of us. So first of all, thank you everyone again for joining this session. So Chris, actually, he's an author of many publications, and he is a Google Cloud certified hybrid multi-cloud fellow, and is a co-founder of Lionkube, right? And Chris has more than 25 years of software and IT engineering experience with the big companies such as Google, Oracle, VMware, Cisco, Johnson & Johnson, and others. And Chris is a regular conference speaker for different international conferences. And me as an organizer, I also have some plan for some workshop in the coming weeks, and also previously organized a lot of free sessions. So this meetup is actually about to help a lot of people have a tech sector interest to come to the tech sector. So what we try to do, we want to encourage people to learn a lot of new topics from the professionals, and also learn the advanced things from the professionals, so they can upgrade their career, and they get more skills what they do in their professional life. And so if anyone has any question at any time, as Chris said, please feel free to ask. And for your information, we're also going to organize some online international conference end of the year, and we'll also have another international conference in person. We're expecting to host end of the year, if not then next year. So please keep in touch with us if you have an interest. We'll have a lot of topics coming up in the coming months with a lot of different speakers. And we are really, really grateful to you, Chris, to have you here in this session. We'd love to learn a lot from you. and we'd love to get more from you in the coming months. We got a lot of attention from you. Okay, so that the quick introduction I want to give. I don't want to hold you for any more. So please go ahead. Thank you.
No, absolutely, Raj. Yeah, I always say that the Google, they're calling them Google Cloud Fellows now, which is a good thing because the original title that they came out was about like 50 words describing certification. And you gave me, so I have a blog which I haven't touched in forever because we're busy working on finishing up the book, which is Core Kubernetes out of Manning. I think Manning's also giving you a free or like 5 free copies as well to give away. So we'll figure out that, and you can communicate back to the folks that are here on how they can, enter. I'll let you handle how we're going to get 5 free copies out to these folks. So let me just jump right in. Appreciate the introduction, Raj. That pretty much covers what I do. I've been working with Kubernetes for about 5 years now, maybe 6. When it gets to that length of time, you kind of forget. And I've been in consulting since 1999, and you can imagine it's been across a wide variety of things. I haven't necessarily specialized in security, but it's always something that we come across. So I'm not a security expert. If there's actually any security experts out there, probably know more than me. What I try to do in building this presentation, and this is actually out of chapter 13 and 14. It's kind of funny. Chapter 13 is about security. So out of chapter 13 and 14, what I did was I broke up a list of things. I haven't gone too much into demos here for this. I always try to let's do a demo and show them how that works. I really didn't do that. What I'm trying to do is communicate to you a handbook of ideas. Like here's a checklist of, I don't know how many. I got 30 slides or so. Here's a checklist of 30 slides that go through various topics. And as an organization, go back and say, okay, well, we're not doing this. And this is like, and prioritize what you folks aren't doing. I start at the container level, and actually, let me get to the next slide here. So hopefully today you're here to learn about a little bit of security. And the way that I've laid this out is not in this order, but that's all right. So the way I've laid it out is we're going to cover some about container security, and realistically, everything starts at your container layer. Then we're going to talk about pod security. So configurations at a pod level manifest and some things to think about. And then we go up another level higher, which is your node level security, which includes the control plane, otherwise referred to as masters in the past. I like to call it the control plane, where you have your API server, et cetera, et cetera. So that's where we're going to go today. And why are we looking at this order? Fundamentally, everything's. Let me tell you a story. One of the more interesting security stories that I have when it comes to Kubernetes. We were building a platform with a client, and we had multiple development teams working on this stuff. A software engineer, just testing some stuff out, installed a copy of Jupyter Notebook. And that's for some machine learning stuff. And what happened was there was a known security bug in that version of Jupyter Notebook. He popped open a load balancer to the world to use and just test out some stuff within this notebook. And about 2 hours later, our monitoring went nuts. CPU usage on that pod and accumulated pods went ape. Like we were looking at 100% CPU usage on this node. And what had happened within 3 hours was a person had discovered that application running on that port, running in our AWS account on that Kubernetes cluster, knew that like they were port scanning specifically for that application, or the list of applications that had intrusions that they could exploit. They ran Bitcoin miner within a couple hours on a single pod, went nuts, node usage to 100%. So what would happen is any other services that were on that node would have been basically ground to a halt. And that's what I'm trying to kind of help you prevent. So that's really why I started the container, is that is your first line of defense. Of course, you have networking, you've got WAF all in front of that, and that may even be handled by another group. But for an exploit, and this came up with Log4j recently, an exploit's always accessible by whatever is programmatically talking to the web, or programmatically talking wherever your application is at. And to me, that starts at your application, your container level. Next level up is pods. And now we're talking about what houses the container. So we're able to secure that more, so that if we have a container that goes a bit nuts on us, we've got some limits on that. And we are also looking at the permission levels that pod has. And then nodes, we've got, of course, everybody's familiar with their API server that kube control talks to. And I call it kube control because that's what David Grant calls it. And he wrote the original kube control, but that's another long story. I won't get into discussions about that. And so we're looking at API server, we're looking at the operating system on your node, you're looking at different components on your node, you're looking at what's going on your node. And that's kind of holistically how I've laid out this presentation. So let's start with the containers. It may be simple to say, and it's always eye-opening. Update your images. Have a CI/CD system that will rebuild your containers. You get Log4j, CVE comes in, you get Heartbleed, you get, we had some really nasty kernel issues, which wouldn't impact CI/CD, but it would impact the nodes. You get Bash, has a CVE, and that's, if you're not familiar, CVE is a big system that we have that allows you, or website system, it's almost like, we call it culture, but it's a ecosystem for security. When Bash is exploited, they put in a CVE for Bash. They have, okay, this is the fixed version, this is the previous version, this is the bug that we discovered. But that's great and all, but how do you get that out to your pods? How do you update Kubernetes? Having a CI/CD system, having software where you can push a button, or you do a PR, you go, okay, I'm going from this, literally I change one line in my container, rebuild it, rebuild the software, push it out. In today's age, you have, like, if you're a company of any size, you need that system within your company. And that's one of the big needs that clients are having, is they don't have that mature of a CI/CD system still. And we've been using, like, I don't know how long Jenkins has been around, but it's been around forever. So we've had CI/CD systems for like 40 years, but until they hit a critical point or they feel enough pain with businesses, they don't typically implement standardized CI/CD systems. The other thing within a container is you want to reduce your container artifacts. You don't want to have Bash. You don't want to have curl. You don't want to have wget. So you don't want to have your build system. So you don't want to have GCC or node build or Go build. You don't want to have any of that. You don't want to have Go installed. So you want to reduce the number of artifacts that you have within your container. What you want to do with that is you want to use multi-stage builds. I've got an example coming up. Most people should be familiar with it here, but a lot of folks still aren't using it. You also want to use distroless. And distroless is, or you can use distroless, or you want to use containers that are specific, or operating systems that are images that are specific for setup to run containers. So distroless is by Google. It's a really good, set of images that are maintained by them. They use them internally. What it is you want to find the thinnest layer of an image that you install your software on. If you're running Java, that's a notorious one where it's very, very big. You need, thank goodness with OpenJDK, you don't need like all the X11 drivers installed. I remember back in the day when you need actually X11 drivers installed to run Java. But they have engineers that know what what they're doing. You don't have to worry about doing this. You don't have to worry about building your own thin images, and you go from there. Also, containers that are specifically made for running, or operating systems that are images that are specifically running for inside a container. You can still run Debian. You can still pull in and build a Debian container, but there's Debian Slim, and you can use that as your base image so that you don't have to go from there. And if you get even crazier, you can build from scratch, right? And you can run like a Go binary with a scratch image in it. So here's basic multi-step build. You'll notice there's two froms. So, and it is just rough. Don't quote me on this build file or on this Docker file. But we specify the build container, which is the first 3 lines here. It's from Golang, set up the work dir, go build. This can be, if you've got complicated build procedures, this could be 200 lines. Now that's running off the Golang image. But what happens is the next from in that line is not running off the Golang image. So you're not deploying Golang image. You're not deploying your image with Node.js build. You're not deploying, say, you've got to pull down stuff with curl during your build phase, GCC, all your build components, all the extra fluff that you need to build your software is not included in here. You, of course, can use 2 different containers. Use one container to build and you use one container to run, but it's nice and convenient just to have this. And it kind of shows you that you've got your dependencies. You're not deploying something. I'm using Alpine. I'm using the latest label, which I shouldn't do here. That's a whole nother discussion not to use latest. So on Alpine, what we're using, and so Alpine, again, is a specific, very, very thin, lightweight operating image that's used for containers specifically. APK is their, we're installing CA certificates here for the application. We've got, and then all we do is copy in our binary that we built in the previous stage. And then the image that goes into your container registry is just the Alpine image. The build container and everything doesn't go in. So again, I talked about distro lists, and this is from their Git repository. Distro list images contain only the applications that runtime dependencies. They don't include shells. They're kind of a pain to debug. They don't have PS. So it's so lightweight. It's so thin. You don't have the binaries you need, except for the specific binaries that you need to run Go, to run your Node.js application, your Python application, etc. To give you, I think their claim on their Git pages, they're about 40% smaller than Alpine, and like 80% thinner than the stock Debian image, and they're based on Debian. And here's an example, we're talking about, again, container specified images. Alpine, the Debian Slim line, Red Hat has one, many others. Just pick one, standardize. Standardize is always good across an ecosystem. Pick one that your company is going to run with. And we go into the distro list example that we're just talking about. So again, we're building from the Golang container in a multi-stage, but now we're using the base Debian 11 image that distro list is running. They have specific, like you're going to need a specific container to run Python, or image rather. You're going to need a specific image to run, say, Java, which is going to be bigger than the base. For Golang, for C binaries, typically, depending on how you build them, C++, etc., you're able to run an exceptionally thin image for those. I'm not seeing anybody pop up on the participant list here. Hope I'm checking it correctly. But no worries on that one.
Okay, thank you.
So some other tips on container security. Here's a big one: don't run as root. So within your image, you specify what user you're running as. Root is root is root. So if you're running as root on a container, you exploit or a baddie exploits and gets onto your node, you're now root on that node, always. And there's some applications like, for instance, Nginx and some others that are kind of snarpickety about not running as root. Run trusted images and move those images from Docker Hub or from wherever into your own registry. So you know, okay, this image doesn't have any exploits in it. I know where this image is from. You know, I have moved it out of Docker Hub, or I've built that image myself, and we own this image now. And that's container provenance is one of the big challenges. For instance, labels are not immutable within an image. So I can push up foo/foo v1.0, right? I can push it again with the same exact tag, and that's not, and it's a totally different image that's in your repository. The SHA is the only component that is you're ensuring that you're pulling down the correct image. Also, again, I mentioned here, update your containers because you'd be surprised how many people don't do it. So I just threw that in again. Screening your containers. Most of the modern container registries have components to screen your containers. I know that GCP does. I know that Docker Hub does. A lot of container registries have it. The challenge is that companies aren't looking at it. You know, we're all busy. We've got so many things going on, but it's not a nice to have currently. It truly is a must in today's landscape that you have to have, one, the system to rebuild, but also the system that's telling you, hey, we're using bash in this container, even though you really shouldn't use bash, but that's a whole nother discussion. Say we're using PS in this container, which is pretty well known. We're using PS in this container. It has a vulnerability in it now. We got to update this. Or one of the kernel libraries has a vulnerability in this image. We have to update it. And more than just, okay, use it, actually have a system that notifies you when you need to do this and prioritize it. Okay, we need like eight man hours a month to go in, and monitor this. Somebody needs to keep track of big CVEs, and that goes for Kubernetes as well as that goes for containers itself, any operating system. Okay, we're going to jump into the pods here. There is one line that you need to have in every pod manifest. That's deployment, like anything that uses pods, daemon set, deployments, like everything uses pods, right? You got to have this line, and that's auto mount service account token equals false. Now let me talk about this. On a pod, by default, there is a service account token that's mounted, and that's for whatever service account that pod is running as. That service account is mounted on the disk, unless you turn it off. And like, okay, well, Chris, why are you making such a big deal about this? The service account token is what you use to authenticate to the API server. So you get somebody that intrudes, they're like, they do ls var run security, wherever it is. Oh yeah, it's there, great. Excuse me, as I exploit, Tomcat that's running, I download or run a bash script so I can exec inside my pod, download curl, because you didn't install curl within your image, but you got an exploit in your software where I'm able to run a shell command. And now I have a token to authenticate against the Kubernetes API server to do stuff. I can, and it really depends on what that service account permissions has, of course. But if that pod is not talking to that Kubernetes server API layer, don't automate the token. Even better, if that pod, and you have the capability of using a security system such as Vault, GCP, identity, etc., pulling a KMS token from IAM to authenticate against the Kubernetes server, you don't even need that pod, right? You need the fact that that pod has a service account, is able to access your security system, get the token itself. That way you can refresh tokens without restarting the pod. In order to change this, you do need to restart the pod, because anything that is at file system level is immutable once a pod starts. Just doing a quick time check, make sure I don't go over here. All right, second thing, and I'm not going to go into an example about this, and it's well documented, but folks just don't do this. It's security context. So within Linux, you have an ID. If you do ID on your bash prompt, right, it pops up your user ID, your group ID, and I don't think it pops up your FS group ID, but I could be wrong. So remember how I said running as root is bad? It's because your ID under Linux is actually root. So even if I am running a container and it has problems that, or like it's another layer of security, which isn't that difficult. It's 3 lines of YAML, and I'll go into the exception when it is difficult. When you've got those layer, or you got the capability to configure your pod, give it a new ID, give it a new group ID, give it a new FS group ID, and pick one that's outside the range of your operating system. You're able to look at etc password real quickly, and I'm pretty sure it's documented that typically Linux doesn't do, like, I usually go in like 30,000 range, or yeah, 30,000 range, and pick a unique ID that's not on your host operating system, not on your node, that you're getting this pod to run as. And what that'll do is the process that your container engine fires up, that user that starts that process within the pod, because you always fork a process to create your application, it'll run as that user ID. It'll run with that group ID. And when it touches the operating system, and when that operating system is or the file system is mounted, it will have also, those files will have unique file system ID. There's a couple of challenges you get into this with this. When you mount a secret under Kubernetes, you're not mounting a file system. You're actually it's a dynamic mount of a volume, which is a secret. And by default, secrets are not, this doesn't go under it. So what you got to do is you got to do a init pod, copy over the secret, change it to the right group ID before you start up the pod. Init pods typically always run as root. So secondly, another challenge they can run into with this is SSL keys. SSL and all that certificates, TLS certs. I think this is one of the banes of our existence as security people, or working as developers or DevOps. When it's very specific that the user, that the ID that the group is running as has to, or the ID and group that the process is running as, in order to touch that TLS certificate, load it, and make a TLS call, it has to be the same ID. So for instance, you've got a secret, it mounts as root, you've got to, in your init pod, you got to copy that secret and get it to be the correct ID and group ID. Another time that this becomes really fun is OpenShift. They've got this the capability of emission controllers, which is a lot of what the security componentry uses. We're going to go over a little bit about OPA, Open Policy Agent. They're all emission controllers, and what emission controllers do is before a pod is scheduled, it runs, and it can either change the pod manifest before it runs, or it can say, hey, I do not allow these set of rules. And one of the set of rules is specifically around run as user and run as group within OpenShift. You've got to jump through a bunch of hoops to get security contexts to run in OpenShift correctly. But you got support when you run OpenShift, so holler at Red Hat and IBM. So next, we're going to jump into some node security stuff. And I'm pushing a little fast, so we're going to have lots of time for questions. So use immutable operating systems. By default, GKE runs on a immutable operating system. By default, other components run on immutable operating systems. So an immutable operating system, if you're not familiar with it, immutable can't change, right? Once it's built and deployed, it's like containers. That's one of the reasons we use containers, because it's immutable. If you take the specific SHA of a container, you're getting the exact same container every time. And one of the big things with engineering is you want to be able to reproduce stuff. Immutable is the same way, and you can do this within bare metal installations. It gets a little bit more tricky, but you can also use immutable file systems as well. So what immutable operating systems does is, for instance, bin/ps. It's on every Linux system. Well, maybe it is. So like varlib kernel pretty much is. We've got to have the kernel to load, and when your bootloader loads your kernel, you got to be able to read those files. Typically, those files are read-only, but root can still mess with those files. So if I get on inside a pod, inside the node, I crack that open. Now I'm able to replace a kernel module with an exploited kernel module, restart the node, and then we're running a new kernel here. Pretty in-depth intrusion. But what an immutable operating system does is it strips everything you don't need. Sometimes it doesn't even give you PS and very little packages and no package manager, actually. And what it gives you is the minimal componentry that you need to run your node. And that's a bare minimal, because like, what's a node? It's kubelet, it's your container engine. That's it. That's a Kubernetes node. And what an immutable operating system does is they're set up to be the thinnest possible operating system for the deployment. Typically, there's some immutable operating systems that, I know Red Hat has one that isn't. I don't know if OpenShift doesn't have a specific immutable OS, but Red Hat has immutable OS, and it's specifically built where everything is read-only. Now, varlog, of course, that goes through systemd and that writes to a disk. That isn't read-only. But kernel libraries, for instance, root actually cannot change that. Root cannot change PS. And the interesting part is, with an immutable operating system, when you upgrade the OS, you got to replace the whole thing. So you've got to reinstall it from scratch. And that's why this works really good in cloud installations, where you're able to roll a whole cluster. And what you do is you get the updated nodes. You get the updated operating system. When it was way back when the CPU bug that we had that was in our kernel, when that bug was found by folks over at Google. They had the fix in before they released the CVE. So they had the fix done in their distribution, which runs GKE. The day that the CVE is released, they had already upgraded the control plane, because they maintain the control plane for you, but they released the new immutable image that you have for your nodes. And then either you go and push the button, which is upgrade your nodes, which, by the way, I don't recommend doing. There's like 3 different patterns you want to use for upgrading nodes. But you roll your whole system. You would install, you could keep your current version of Kubernetes and get the new operating system, or you could upgrade Kubernetes and get the new operating system. The other thing about immutable operating systems, where they're built specifically for Kubernetes, typically when you roll the node, the operating system is also pinned to the Kubernetes version that you're rolling. And that way you're getting specifically read-only components. It's secured. It's the tightest, security that I know of for an operating system. And you get that with your Kubernetes version, then you have a node. And the nice thing is, Kubernetes was really built for this, right? If you're looking at the old practices that we had with, running our Oracle database or running our Java app on a VM, the thought process behind shutting off the capability of node, cording it, that process didn't exist within the infrastructure, and that's one of the bonuses Kubernetes gives you. That's why it's so made to run immutable operating systems. All right, so this is a pod configuration, but I put it under nodes. because it can be done both at the cluster level and the namespace level. So that's a node level. And then it can also be done at the pod definition level. And remember back to the story I told about the runaway pod that we had that was doing Bitcoin mining, and how our node got to such, like, it just killed CPU on the node, which does weird things to networking, by the way. You can't have networking work on a node if you don't have any CPU for that networking to work off of. So the pod didn't have any resource constraints on it. Resource quotas you can set at a namespace level, I believe, or so you're saying I'm getting this many CPUs, this much RAM, and this much disk to this namespace. But even more than that, you need to profile your pods. You need to profile, okay, this deployment in this pod needs 0.05 CPU. So we only need, you only need, like, you don't even need a full CPU. You don't even need a half CPU. It needs 0.05 CPUs. And you can specify that right in your pod. It's 2 lines of YAML. You can do limit uppers and lowers. And all these are upper and lower, it varies. We have burst models, we got QoS. I'm not going to go into all that because it's not, it's realistically, the details aren't important. What's important to me, you can go Google that. That's one of the reasons, I think the fact that, we're such good engineers is that we know how to use Google really well. All of that's well documented by Kubernetes folks. I've got a section about my book, etc. Right? And there's many blogs that talk about this. Used to have some bugs with this, but they've cleaned up all the bugs in terms of burst models. But you're able to over provision a node, but yet still control the high level limit of where you're bursting to. And you're able to put in the constraints where you're not, so you can actually do like a denial of service attack with resources. So you're hammering a pod or like external, or you do something crazy like you spin up 1,000 pods across a cluster, and CPUs go nuts and TCP traffic go nuts because you spin up all the health checks at the same time. You constrain what's going on with that pod from a memory, disk, and CPU level. And it's really challenging to do this, to be honest. You have to have a profiling system in place. Your developers have to understand that they have to go through this process. And you need something like Prometheus or another monitoring system that will say, hey, this pod isn't performing well. You can use auto scaling to do that, but realistically, you should be able to profile your pods and put tight constraints on it. Because even with auto scaling, if you have auto scaling enabled for this, and the resource quotas get adjusted by auto scaling when you do vertical auto scaling, you're still, it's not managing, and this is kind of some of the black magic that dark magic, I would say, that's with it, that's not well known. It's sizing of like, how big is my node supposed to be, and it's sizing how much memory my pod and how much CPU my pod gets. And it really takes testing, load testing, a system in place like Prometheus, which is really becoming kind of an industry standard, people that understand that and they're educated how to do this. And realistically, unless you like with most microservices, they're very tiny. And if you have an application that's very large, you're probably already used to performance profiling it anyways. For instance, Cassandra, if you have that up and running, it's got all the hooks in it though, where you can look at the data. What is it using? How do you set it up correctly, et cetera, et cetera. In a microservice world, it's very different. You're running, say, hopefully you're running like 100 pods in your node. That way you get the correct node density, but your pod density on your nodes, and save yourself some money. But you wanna have a system in place where you can build these numbers, tweak them, be able to adjust them on the fly. One thing, these are typically stuff like this, and you can tell when and this is an aside and kind of a trick, you can tell if you can adjust this on the fly, or if you can modify something in a pod. You can do kube control edit on that pod. One of the things is, okay, do I have to restart the pod to do this, or can I dynamically update the pod at this time? You can do kube control edit, and you can, if the API server and kubelet and your runtime container can modify this on the fly, this value on the fly, and there are some values like tags, for instance. If you can modify on the fly, kube control edit will allow you to do it. Otherwise, it'll complain at you that you got to restart your pods. So just an aside. Pod networking. This is one of the really we're going to go through some stuff here. It's one of the really complex topics, I would say, that we're hoping, as a ecosystem community, we hope to make easier. There's a couple things. So you have your CNI provider, and that's container network interface. It's how pods get their IP addresses. You have logging. So you got all these daemon sets running around that are specifically built so that your pod, they're like the way I would say they are, it's like Kubernetes is a virtualization almost on top of a Linux operating system. So you've got to have that virtualization layer, and that's logging, that's networking, that's security. All of those componentries are a layer down from your pods. There's two different networks. There's a single line YAML, and you move it from the pod network to your host network. Now, guess what? You do that, you're running on your friggin' host network. So you can curl kubelet directly unless the port's blocked. So any port that's open on your node, such as kubelet and cAdvisor typically, you can curl that directly. So you're now on that network layer. You're not in the namespace network layer. Depending on your networking model, there's a lot of different networking models, but a pod can have its own Linux namespace, not a Kubernetes namespace, and that isolates that pod. And it really depends on, we're not going to get into how pod network works and all that information, but typically, unless you define it, you're going to run in the pod network. Unless you're creating something that's completely administrative, needs to talk to the host network, needs to possibly talk to the host file system, you do not run on the host network. Networking policies. Nobody does this. Let me just say, like, I haven't been in a company where I've seen an organization do this. Kind of troubles me. And this is kind of claim to fame that, in the next one as well, that a lot of service meshes are going to do. And service meshes, I don't think everybody needs a service mesh. It's the latest topic of the week, but I don't think everybody needs a service mesh. There's some great ones out there, but I like keeping stuff simple. If you don't need all the functionality of a service mesh, don't bring it in. I see somebody in the waiting room, actually. Yay. So I admitted them. There we go. There's hopefully my Zoom administration of the day that I need to do here. Network policies are a typical out-of-the-box feature that you enable. You need, like, Calico networking provider runs it within GKE. AWS CNI networking provider has network policy capability. I always mispronounce. Cilium is another networking provider for Kubernetes. They can do networking policies. Not going to get into what they can do, but it's like firewall, right? So within a Kubernetes cluster, when you're running on the pod network, you have namespace alpha, you have namespace beta. Every pod can talk to every other pod by default. Now, if you have a trust policy within your organization where it's okay, we're not multi-tenancy, it really doesn't matter. We don't have HIPAA, we don't have SOX. Great. Every pod can talk to each other pod. That's fine. But a lot of organizations need to do this. One way that large organizations get through this, is that they have a Kubernetes cluster per group. So instead of fine graining at the namespace level and protecting at the namespace level, you don't. What you do is you have separate clusters. I know organizations, and there's a little bit of detour, I even know organizations that have one app per Kubernetes cluster, and they have about 900 Kubernetes clusters. Kind of crazy, wouldn't do it, but hey, that's what they do. Another thing that we're talking about is really, if you want to get into securing network traffic, you want to look at mutual TLS, Envoy, Istio, all the folks in the service mesh namespaces does this. Also, servers meshes, of course, have large capability of adjusting your network flow and protecting your network traffic. And it really goes back to the interesting perspective that as DevOps engineers now, we need to understand networking. If you're been around the block like me, I've been doing this for a couple of years. You have been exposed to either working with networking engineers or you've done enough networking that you can hold your own. But as DevOps engineers, that's like when we're hiring, I ask the questions and I can tell who doesn't understand pod networking. I can tell who doesn't understand general networking, that we're flowing through load balancers, that we've got firewalls that we got to worry about and all that. And your network policies and other things are your firewalls or your VPNs within your pod network. Protect your API server. That is remember I talked about the pod talking to the API server. Well, your CI/CD system, for instance, needs to talk to your API server. Your developers need to talk to your dev API server. Use a VPN, use NAT gateways, private API servers. You should never, ever, there's no use case that I know of to have a publicly accessible API server. If you have to have it, if it's like some playground, you're opening up, it to the world for some reason, your training company or something, use ephemeral servers where you tear them down, upgrade it often, and whitelist the darn IPs on your load balancer that's in front of your API server. Can't say it enough. If you're going to attack the control plane, you're going to attack the API server. Every control plane component, all the kubelets, everything talk to the API server. It's one of the most vulnerable points that we have, and we've had a lot of bugs that have gone into the API server that we find. Remember a nasty release where we had there's no authentication, and that release went through, and of course CVE was created, went through the fire drill. Again, it goes back to one of the principles of protecting your API server is be able to upgrade your system very quickly. It can't take days now for you to upgrade to a new Kubernetes version. It's got to be a much shorter period of time. Protect API access. Now, this is different. We talked about protecting the API server. Now let's talk about permissions. Pod shouldn't have API level access if they need it. If they need API level access, they need the appropriate service accounts, groups, users, RBAC rules, cluster rules. They need that mess of RBAC. If you ever played with RBAC, you know that it's complicated. There's some tools out there that really allow you to parse what's going on with RBAC. You should be doing the smallest, limit your pod to the smallest amount of calls. You're able to fine grain the calls within RBAC. I'm not going to get into RBAC. That could be a whole presentation. And there's plenty of great ones out there. I think Legit has one that's amazing. Sorry if I used his GitHub ID. Give out admin kube control access as appropriate. Create developer accounts. Even if developers can do everything on a node, don't give them the same service account capabilities or the service account that you created, so that you have a root, right? Very few people within your organization should have that access, the root access. Or you can do you do the whole inverted where everybody has root, and that's fine too. You just need to know how to manage that and how to turn off permissions very quickly. And also the inverse goes. So the service account that your Kubernetes cluster is running with, and I think we talk about this in a bit here, has capabilities in your cloud as well. So we'll get into that in a bit. Yep, there we go. Cloud-based considerations. And this goes into IAM specifically. So you've got your API server, and typically you're using authentication that loops back to your cloud. It's kind of like LDAP server, right? Back in the day, we had, we logged into our email, we would be hitting the LDAP account, username and password. Well, there's a bunch of different wrinkles with Kubernetes and how it's set up in the cloud and the IAM permissions. And the IAM permissions that Kubernetes has is nuts. You know, we can create load balancers. Like 5 years ago, I was having conversations with a bank that they're using, I won't say who it is, but they're using Kubernetes a ton. But if you think about it, your cluster can create elastic load balancers that are public. And within 2 seconds, you've got an internal service that's exposed because of one line of YAML. I'm going to get into some stuff that you're able to protect your manifest with that. Cluster account, never use the default account, never use a user's account to create a Kubernetes cluster with. Always create an IAM role, an IAM account with the least permissions available that you need in order to create your account, because typically you need to give the Kubernetes cluster its own account. Now, pod accounts, that's another thing you get into, but because typically a cluster has its own account, that account is also the node's account, and then the pod has that account as well. So in theory, if you authenticate with your pod account, and Google fixed a bunch of this stuff, but there's still ways to get around this, and you got to think about this. A pod may have the capability to create an elastic load balancer, may have the capability of creating a virtual machine. Now, there's lots of ways to get around this where you're actually setting the IAM role of a pod, or you give it no IAM role. And then you've got to use a system like Vault or another, all the built-in cloud authentication systems where your pod goes and gets a token that it's able to connect into a database with. Another way that you can do this is you have a sidecar that's running that has the token, and they have this for Cloud SQL in GCP. So you have your pod, and within the pod has 2 containers, and your pod talks to a proxy that then talks to the cloud resource for you. And as I mentioned, cloud resources, right? We've got to take the standpoint that, and remember, my EKS cluster on Amazon can create Amazon resources. It can create load balancers, file systems. It can create nodes. EC2 instances. It can create everything. I'm not saying everything, but just think about it. I personally went through the laundry list of IAM because our IAM permissions on COPS. I'm not sure if anybody's familiar with COPS, but I can point you to the word source code, but it's hundreds of IAM permissions that we have coded in Golang to specifically what does a Kubernetes cluster need. So when you set up your role and your account, you've got to take that in consideration. Most of the modern cloud providers have a role that is, okay, this is the role you need for your EKS cluster, but that may not have the capability of reaching your database. So you need to remember that, okay, I'm going to hit cloud resources. I'm going to need to authenticate within the cloud. Your pod's going to need to authenticate that way. And here's the big thing. I've gone through a lot of stuff, right? We've got to use automation tools. People forget, people get busy. We've got to reduce. And here's the balancing act. And I'm going to talk about this at the last point to wrap this up. But open policy agents, pod security policies are going away. We've got new things. So we've got all these tools. We've got these harnesses. We've got linters like Hadoop lint, which is a great little linter. It lints your container files for you, your Docker files. And you're really able to get a listing of all the security issues you may have. It really tightens up, right? Implement these into implement your linters into CI. Set up your system that talks to your container registry so that you get information from your container registry. If you need to automate that. Remember, mission controllers are one of the things I talked about. Use stuff like open policy agent, great CNCF project. What it does is it, for instance, with rules, with business rules and security rules, you're able to say, I am not able to deploy a deployment or install a deployment into a Kubernetes cluster that is loading an image outside of our registry. I have a registry that I have to use. I cannot launch a pod from Docker Hub. I cannot launch a pod from a developer's local registry or whatever happens, right? If you're controlling, if you want to make sure you got to have provenance, there's no way to control provenance automatically. In other words, knowing where the heck you're getting that container from. There's no way to do it automatically within Kubernetes. You've got to have an emission controller like Open Policy Agent. Come a long ways. OpenShift has all their own stuff. I'm sure other, there's, Aqua Security, and there's all these great third-party projects. I'm not going to say, I'll talk about the open source because it's free. Great. I'm not going to say, hey, go buy Aqua Security. I'm not going to say, no, go buy Aqua Security. I'm going to say, look at the automation tools, spend your money wisely on that. Multi-tenancy. Let's talk about this quickly. Well, we've got, actually, this presentation was the correct length because we're getting near the end here. Multi-tenancy. I have a company and I want to host other companies' pods. So I'm providing Kubernetes as a service. Kubernetes, I hate to break it to you, we haven't fixed this yet. When we created the API server and when Google laid it out and other developers worked on it, Kubernetes is not built with a zero trust model for multi-tenancy. Container images are barely now coming to the point of maturity, and you can't run just regular container images. You got to run a virtual machine and a special version of Linux that allows for zero trust multi-tenancy. What do I mean by zero trust? User A application cannot touch user B application. That's zero trust. They're two different companies. They're two different departments. We got HIPAA issues. We got SOX. We got, lions, tigers, and bears, oh my. So those two applications cannot talk to each other. You cannot have them within the same Kubernetes cluster. It just doesn't support it. The API, for example, really easy command, get kube-control, get namespaces. That gives you all the namespace names. If you can get namespaces, you can get your own namespaces. And we can't nest namespaces. So what would need to happen is that we have an API layer where you have the user in the URI is one of the structures we could use. We haven't. We just haven't done that. AWS APIs, for instance, it uses a user token. You're calling the same API, but behind the scenes, you're not getting, your competitors' lists of virtual machines. You can do medium trust, sorta. And you can definitely do multi-tenancy without worrying that we're walking all over each other. Medium trust can be set up where teams have their own namespaces. You have node group rules where a team's applications are specifically running on their own nodes, and you're not mixing across. So we can do that, right? We can do different trust models, just define what the heck your trust model is and figure it out from there. And it goes back to where if you are running in a European country where your data laws are really fun, it's sarcasm because data laws in Europe are quite complicated. It might be their approach where you have a single application running on a single node, and that's your Kubernetes cluster. And you get the benefits of Kubernetes, but you're just single application. Now you got to administer now 900 different Kubernetes nodes. But, typical multi-tenancy trust model or trust models within a lot of companies is search has their own Kubernetes cluster. Machine learning has their own Kubernetes cluster. And then they don't talk to each other, right? Set up APIs, set up API authentication. That's handled at the API layer. That's not handled at the Kubernetes layer. You're not worrying about containers going across. GAdvisor, for instance, is one of the products. So this doesn't only deal with Kubernetes, it also deals with containers. But GAdvisor, for instance, is one of the newer technologies, probably not for 2 years now. And that's GKE. There's a bunch of other virtual machine technologies. I forget the name of it, but Amazon came up with a really cool one. They all provide the capability of doing more multi-tenancy, but still it goes back to the API server. Kube-control, get namespaces. You could see other people's namespaces. And if you have the right RBAC permissions, you're able to create stuff in other people's namespaces. And this is what and it goes beyond that. CRDs, everybody's using CRDs nowadays. They're where you're able to define a API definition dynamically within the API server. I think it's really cool. But a lot of folks are using them now. But CRDs are not namespaced, so you can have one CRD per one CRD installed of a certain version in a cluster at one time. So, and there's lots of other API structures that are like that. So let's recap. We talked about container security. Update your containers. Don't run them as root. Look at locking down the IDs, and then that goes in, or I'm sorry, that goes into pod security. Skip there. In terms of container security, use a lightweight container. Pod security, lock down those IDs. Look at the security context settings. There's lots of things that we didn't go into. You can run SE Linux, you can run AppArmor, and there's lots of cool toys. But I'm going to go into why I don't talk about those. And then node security, right? Upgrade your operating systems, use an immutable operating system, have networking lockdown within nodes. Use mutual TLS if you want to encrypt traffic between pods. And this is the interesting thought I'm going to leave you with. Security and DevOps might be our job, but that's not how the company makes money. And what do I mean by that? Company makes money through sales, innovation, selling a cool product. We have, as engineers, we have to support that. Outages, because of security issues and leaking of customer data, is a risk. But the question is, how much security do I put in to mitigate that risk? And it's a decision you got to have internally within your group. And if you have a security department with that, with your CISO, if you have a chief security officer, you got to have that discussion. And it's okay. Here's a laundry list of stuff that we can do to help with security. But we haven't talked about training here, right? Training so that developers don't check in production data and don't move it into a test data account, and then that test account gets attacked, or passwords go into source control. There's just some basic things that we need to be thinking about every day as developers, as DevOps people, that we do, the human factor, right? That doesn't slow us down. And or is the simple way of mitigating risk, the automation, putting an open policy agent, having a mandate, hey, we got to profile our pods are going to run better anyways, we're going to save a bunch of money, we're going to be, there's lots of reasons for this. So, but don't go to the extreme is what I'm saying. Don't go where we have to do this. Kubernetes is not secure. We can't run Kubernetes with all these things. No. 80-20 rule is the thing I live by. Take 80%, find the low-hanging fruit, implement that, implement the tooling around that. Your CI/CD system can run linters, right? Run Hadoop limp over it, and help out your developers with training, help out your DevOps staff with training, help out your people with systems. So try to leverage and not try to mandate. Is what I'm saying, because we all got to make money. I wish in my 30s I understood how important sales was, how important marketing is. As engineers, there's a lot of really successful companies out there that have software that they sell, and it's not great, in my opinion. And it's, as engineers, we're here to support the company in making money, and the reason is because we want paychecks. And if the company ain't money, we don't stick around. And the same thing, let's talk about this as well, is you've got to be prepared for, and you got to put the systems in place and documentation in place that this is what happens if customer data gets released. This is what happens. We've got to track the CVEs so that we're not running Elasticsearch that has log4j in it that now has an exploit where I can run, it can get cracked, and I'm running a bash shell script, and I'm doing all kinds of fun stuff within your Kubernetes cluster as in a bad person, not me. Yeah, that's pretty much it. Let me go into a couple things. Got a book coming out. It is out, actually. It's in MEEP. Actually, you can replace that now with the actual cover. We went, Jay and I want to talk about Jay Vyas real quick. He works for VMware, core interest group, great guy. Book wouldn't have happened without him. This is really his book. I'm just good at talking and help writing and fix as well, of course. What we try. This is how networking works within Kubernetes. This is how CIDRs work, et cetera, et cetera. So, it's a little bit more advanced. My marketing department wouldn't be happy unless I put this in really, really quick. I'm not going to expand on this, but Lionkube, we're a professional services company. We're always looking for good engineers as well. And we help out some really great clients with their Kubernetes and DevOps needs. Appreciate you folks hanging around. I know we got a couple things, 5 things in chat. So let's go through those real quick. Anything in Facebook? Raj?
Yeah, thanks, Chris. It's really amazing to see a lot of security points you covered, especially on Kubernetes, like the pod node. So I collected few questions actually. So one of the question I got from one of the guy from the Facebook to send me. So the question is, how do you know if an attacker gained a foothold into your containers, pods, or host?
Yeah, and there's intrusion systems, right? A lot of third-party systems will help you. But one of the main things is have good monitoring, right? If, for instance, if you're outbound traffic, like it's what is happening differently. If an intruder gets in and they make one command, you might never know. But if a intruder gets in and starts Bitcoin mining, or starts accessing CPU, if you're pegging stuff, and pegging, I mean, you're at 100% pod, like you were the good person, you put in, or not good person, but you were judicious and well educated and did the right stuff by putting in the right constraints, but you have to know that your pod hit 100% CPU, and you should know that anyways, right? But it's putting in the right dashboards, the right type of monitoring. There are third-party products as well that can look for there's even complex stuff now as artificial intelligence that'll look for intrusions. So all kinds of cool stuff, but you got to pay money for third-party products. Typically, Grafana and Prometheus are great to spin up and get those PagerDuty alerts running when you start spinning up pods that are 100%.
Cool. Thanks for that. Yep.
Anything else from Facebook? And then looks like we're talking about virtual networks, and I want some more details on what we're talking about virtual networks.
Yeah, actually, I think that guy actually dropped who asked that point. Okay. So maybe the 2 points I actually have. One with I work with the different banks. Okay. I work as a principal architect, so I architect different banking solution.
Yeah.
So we see a lot of times the engineers they face the challenges in terms of how can we put a lot of compliance policy at the runtime in the Kubernetes cluster, Right. So and you mentioned that service mesh may not be the starting point for a lot of time.
No, a policy agent really is your starting point. But go ahead. Sorry.
No, that's fine. So just to ensure that the encryption of your internal pod communication, and you don't have any vulnerable access into those pods. So what do you recommend for the people to follow?
Balance. So first is looking at how you're setting up your Kubernetes clusters. Make sure that you're setting that up right? Use Terraform. It's all, to me, it's layered, right? Start with creation. Get the creation done. We're working with clients right now, and I know big companies out there, they still push the button in the cloud interface to create their Kubernetes cluster. Can't do that. You got to use infrastructure as code. You got to have documented well in playbooks. Secondly, so you've got that running. Now decide what your trust model is across within your Kubernetes clusters. Are you going to use multiple Kubernetes clusters for different divisions? Are you going to look at data, right? So you could put all of your PII services, so it's private and protected information. HIPAA is another one. You put all of that in one basket and monitor the hell out of that one basket, right? That way you've got really tight control over that data, over the services that are critical. Put them in their own Kubernetes cluster. And also, but it's policy agents, right? In policy agents, it's not just running an emission controller in Kubernetes, but it's also, you can lint stuff like Hadoop lint in your CI/CD system, right? Run the linters, run a Java linter that can find possibly security holes in your Java code. There's great open source stuff that's been out there forever. And then if you want to get more extreme about, or next layers, look at open policy agent, look at third-party product as well. There's lots of paid products in the space now where you're building business rules over the basics, right? I can't create a service that's an elastic load balancer by default. Everything has to be internal. I cannot, as a developer, cannot check in a manifest that gets deployed automatically out to test that creates an external elastic load balancer. Easy, that's what open policy agent's made for. I cannot, or a developer cannot check in code which creates a pod that doesn't remove the service account token. Like all the little things that I talked about in this, you're able to have an ingress controller. Which what will happen is the last line of defense, right? Your ingress controller will not allow you to do XYZ action. It won't allow this manifest to be sent to the API server. It's actually part of the API server process is before it's saved and run through the control plane. It goes through all these business rules, and it's pretty cool. I've got a section about it in the book. I should really write a blog post about open policy agent. Personally, I think it's really cool because you put this stuff in place and what do you got to do? Upgrade open policy agent. It's there. You could have it standardized. I have to use this container registry because, like I said, one of the main things we need to do with containers is we need to upgrade them. So if the developer is able to pull in a container from Docker Hub, I'm not saying there's anything wrong with Docker Hub. What I'm saying is there's got to be some containers up on Docker Hub that don't pass the, got old operating systems in them that have got security holes in them. You don't want that. You want to understand and control what you're running on your own cluster. And I made mistakes myself. We're all busy trying to meet deadlines. So have a good system in place that covers your work better than you can. Any system that we put in place, in my opinion, can catch boo-boos easier than we can. And PR reviews as well, right? Have security in mind when you're reviewing each other's code. Have security in mind when you're looking at Terraform. Is this so it's training, it's tooling, and it's just it's figuring out what security policies you're going to put in place and not cost the business so much money it's not making money and you're not able to release your software on time. It's a balancing act.
Yep, thanks for that. I think also maybe the policy, we need to put some sort of alerting and monitoring, automated.
Mm-hmm.
In case the policy detect there is some vulnerability.
Well, CI will fail, right?
Exactly.
So, but your point, CI has to know that it's deployed into the cluster that's running properly.
Yep.
Right. And then you have to have an alerting system on that CI will bail. CI failed, and technically you run Helm command or you run a kube control command, it's going to fail that deployment failed. But you got to do that kube control watch. You got to watch that service comes up. You've got to have the smoke test that causes CI/CD to fail, that it can't do the status curl, that the pods aren't completely up. Right. You've got to, here's another wrinkle, right? We're using operators, right?
Yep.
People forget to monitor that an operator did something wrong, that we created a CRD that caused the operator to create a manifest that a stateful set, for instance, create the stateful set, but is against OPA. So if OPA will tell the operator no, and it's one layer removed, the CRD creation the CRD or the CR, actually, custom resource was created properly, but the database didn't get updated. So
yeah, cool. Thanks for
any
that.
other
Yeah,
any other Quais was asking, is this recorded? Yes, this is being recorded. Raj definitely will get it up, and we'll get it up also on Lioncube's YouTube channel, I think.
yeah, we also have a
I'm
YouTube channel.
gonna steal that from you. I will share these slides as well. I'll get Raj the link to these slides. I'm gonna clean up a couple things that I noticed. This is the first time I ran through presentation. By the way, I'm open to feedback. I did not include a lot of demos in this code. I didn't talk about a lot of things to show, hey, this is how it works.
Yeah, I think
if you can give me some feedback on, hey, you'd want some more demos or, anything like that. And if I missed any topics that you feel are important with security, please let me know. I'm Chris Love, CNM. So it's ChrisLove, and then it's Charlie Nancy Michael. That everywhere, including LinkedIn and Twitter, please reach out.
Yep. Thanks, Chris. I think it's really helpful. And actually, I have 2 more questions. I'm not sure whether we have 5 more
Yeah,
minutes.
I got time. Totally. I've got till 12 blocked off.
Yeah. So I'll just go very quickly, 2 more questions. And thanks for all this information. And this will be all live. This will also it's recorded, and we'll make it available on our YouTube channel, and I'll also share with you, Chris. So 2 more quick questions, Chris. Maybe if you have time, as I said, just very quickly. So
I literally have till 12 blocked off, which is 40 more minutes from now. So shoot.
Sorry, I think it's a night time your side, isn't it? It's late night.
No, it's almost lunchtime here.
Oh, lunchtime.
So,
okay, sorry.
Yeah, other way around. I'm not in India. I'm in Denver.
No. I had another guy from Australia, so I.
Oh boy.
Yeah.
I'm wide awake.
Yeah.
So shoot.
Yeah. Thanks for this. 2 more quick questions. One is like, let's say we don't using the service mesh, so but we want to access external services from our Kubernetes cluster. So what are the security concerns we need to be aware of, and what sort of a process we should put in place before we raise those calls? Yeah.
So what you're asking is, and let me know if this is the question, you've got a cloud database that you're running in your cloud.
Yep.
Your pod has to access that cloud database.
Yeah, or maybe another external service, let's say.
Right, an external service. Yep. It doesn't. So the considerations are, how does that pod get the IAM token or authentication token? Right. That's the first concern.
Yep.
Don't use Kubernetes secrets. I didn't cover that. Kubernetes secrets are not a secret system. Let's put it that way. They are encrypted at rest, but when you retrieve the service, it's just in base 64 encoding, I think. So you have the capability of retrieving a secret, you can decode it, and you got it in plain text. So don't use Kubernetes. Mature systems do not use Kubernetes secrets. Let's go there. There's some great security systems out there. Vault, clouds have IAM security systems. So here's the life cycle. You've got to somehow, that pod has to authenticate with the security system, or has to have mounted with a secret. And then you've got to authenticate that way. And then you're able to authenticate with the resource, whatever external API or whatever. And it goes back to password management, right? From an API level, which is use short-lived tokens, have the capability of changing those roles and shutting off those roles very quickly, and have that transaction monitored. So if you've got, like, how easy, it goes back to rolling certs, right? How easy is it for you to roll your TLS certs? How easy is it for you to roll your SSL certificates? How easy is it to roll your passwords? It's having a system, either use cloud-based system, use HashiCorp system, Vault, use whatever password manager system you love, authentication system, and use an external system that you're creating a short-lived token, and that you're able to do this, and that pod can't talk to anything anymore. As well as, don't give human beings the same type of capability in production that the system's using, meaning a developer will need to be able to log into a database in dev. A administrator will be able to log into a database in dev, but don't give them that same capability that a pod has. You know, you should have your own logins. That pod should have a login. You should have a login. So when you leave the company, we're not changing that pod's login. You know, that's the risk, right? Is having the capability of rolling and changing passwords and having a system that does that and having it monitored. It's whether, you know, my take on APIs and access, it's pretty much the same type of, you know, process that I use even within a Kubernetes cluster. You know, if you have a pod that's able to access the API server, it's accessing API server. You got to have the same controls in place.
Cool, thanks. I think it's really good the way you explained. Nice. So you mentioned that your books, you're gonna give some free books. So so do you think how our members could access those, or if you can link?
So you should have let's talk about offline. But what I would say is that we figure out you know, a system where they can log in. I think we have the names capture the people that were here. And there's like 7 here, I think, but I don't know who's on Facebook. But just tweet out, hey, you know, if you retweet this, you know, video, you'll be put in a, you know, I can coordinate with it. Marketing folks can help you that, you know, if you retweet this video, you know, or publish it to social media, well, you know, you mention us on LinkedIn, or you mention us on Facebook, or you mention us on Twitter, or something that we come up with. You know, Twitter's always an easy one to track, right? And then I think we have 5 copies of books. So.
Okay, cool. Thanks. I think it's a great session, Chris. Again, you covered a lot of core question actually on the community side. And,
Thank you.
And I would love to, like, we learn a lot from you, and I think our members also, a lot of Facebook share. So hopefully we can have more sessions from you in future coming days. And yes, we would like to encourage people to retweet or tweet and then get the benefits of getting some free books. It's nice to talk with you and get you into our meetup. We are pretty much very much grateful to you to cover this very industry-wide topic. It's very important. From an
I had fun. Yeah, I definitely appreciate it. Had fun joining folks, and also nice thing is that had a lot of fun writing these 2 chapters in the book. It's interesting to me. Former military, so kind of comes from part of my background. But yeah, interesting stuff, and often interesting business discussions when security has to say, no, we actually should do this. But then just remind them how much downtime costs and how much bad press you'll get if you suddenly link customer data. So.
Yep, I agree. Cool.
Awesome. Thank you so much.
Thanks so much for your time, Chris. We'll catch up again, and we'll try to organize future session. I'll keep in touch with you offline. And thank you everyone for joining today's session. Have a great day. Thanks, Chris.
Thank you. Bye-bye.
Bye, everyone. Thank you.